In this video, we are starting section 1.3 on exponents. Okay, so our goals for this section are to evaluate exponents and roots. We're going to review some of our exponent and root properties, recognize when roots become absolute values, and then also talk about rationalizing numerators and denominators. Okay, so a lot of the stuff in this section is the stuff, just like the stuff that we saw in previous sections, is stuff that you would have seen before. It's going to be a lot of review. Okay, so we're going to be able to go perhaps quickly through some things and maybe a little bit slower through other parts. Okay, but let's get right into that. Let's get into some examples. Okay, so I want to talk about integer exponents first. So I want to compute each expression if it's defined. So actually for parts A through D, I first want to give you time to try these. So take a minute and try these on your own first. So pause the video in 4, 3, 2, 1, pause it and try those on your own first. Okay, so hopefully you did that. These are all pretty quick, so I think we can kind of fly through some of these. So 2 to the 3 means I do 2 times 2 times 2, 3 times, and that's 8. Awesome. For part B, I have a negative exponent. So you might recall that what happens there is I get a fraction with a 1 on the top, and then I bring this thing to the denominator, and when I do that, the exponent switches sign. So as 2 to the positive 3. So that's going to be 1 over 8. Okay, and that's my answer for part B. So what if I had a negative exponent, but it was on the denominator? Like what if I had 1 over and then 2 to the negative 4? What if I had something like that? Well, that 2 to the negative 4, I can move it up to the numerator. And when I do that, it switches sign to become positive, and I'll get 2 to the positive 4. That 1 is still there, so this whole thing is times 1. Now the 1 in the numerator is still there. So 2 to the 4 is 16. 16 times 1 is 16. Okay, so that's how I can evaluate a negative exponent when it's on the denominator. Let's go to part C. Part C, I got 4 to the 0 power. Okay, so if I have something to the 0 power, and it turns out that as long as this base is not 0, well, the whole thing is 1. That whole thing is 1. Okay, and then what about part D? If I have 0 to some power, 0 to the 5, sorry, well, that means 0 times 0 times 0 times 0 times 0, 5 times, which is 0. Okay, alrighty. All right, so we have 0 to the negative 4 power. So I bring that to the denominator, and it becomes 0 to the positive 4. So 0 to the positive 4 is 0. And if I divide by 0, we've seen that's undefined. No, this is undefined. Okay, so we've seen that if you have 0 to a negative power like this, it's undefined. If I have 0 to the positive power like 5, it ended up being 0, because I could do that multiplication. But what if I have 0 to the 0 power? What's that going to be? So there's kind of two things at play here. If I have some number a as the base and 0 as the exponent, as long as that base is not 0, I get something like C, something like 4 to the 0, and that's 1. Okay. What if it's the other way around? What if I have 0 as the base and I have the exponent a being some positive number? Well, that's like D, that's like 0 to the 5. That ended up being 0. So as a result of this, it's kind of unclear, it's uncertain if 0 to the 0 should be 1 or if it should be 0. There's no kind of clear way to define it. As a result, 0 to the 0 is undefined. So 0 to 0 is undefined. Okay, all right, let's move right along and let's review fractional exponents and roots. Okay, so I want to get into a definition first. So definition. So if a is greater than or equal to 0, so it's non-negative, and m and n are integers, when I write a fractional exponent, a to the m over n power, that means I do whatever's on the denominator, that n, that's the type of root, so I get the nth root, and the number on top of this fractional exponent, well, that becomes the power. The m is the power. And I can also switch the order of those. Like I can put the power inside. Whoops. I can put the power inside and I can put the root outside. Sometimes it's going to be quicker to do it one way versus the other. And we'll see an example of that in just a bit. All right, let's look at part G. I got square root of 64. So the square root of 64 here. So when I'm evaluating a square root, I'm trying to find a number, x, so that when I square that number, I get 64. But there's two things that work. Both 8 and -8 work. So both of those work. So which of those is going to be our answer? Okay, so there's something we have to be careful about. When I have the square root of x, that is a function. So square root of x is a function. And a function can't have more than one. A function cannot have more than one output. So that means it can't be both 8 and -8. So the convention is that with the square root of x function, that we take it to be the non-negative square root. We take it to be the non-negative square root. So as a result, with square root of 64, well, we say the answer is just 8. It's not plus or minus 8. It's not -8. It's just 8. Because there's got to be just one output, and the convention is that we pick it to be the non-negative output. Okay, so a couple things about this. One is, when you have a square root, well, that's a type of root. We can write that as a fractional power. So this is 64, and a square root means I have a 1/2 power. So the 2 in the denominator tells me the type of root. In this case, it's a square root. Okay. All right. So you might remember from like algebra class before that, wait, sometimes with square roots, don't we get pluses or minuses? When does that happen? So we get a plus or minus when we square root, let me switch color here. When we square root equations, when I square root both sides of an equation, like x squared equals 64. If I have that and I square root both sides, on the left side I get x, on the right side I get 8. And you might remember that from algebra class that when you square root both sides of an equation, well, you got to put a plus or minus on one of the sides. Okay. On the flip side, though, if the square root is already in the problem, like I had with square root of 64, well, then there's just one value to it, and it's got to be the non-negative value. Okay. And the key takeaway from this is, with equations like x squared equals 64, they can have more than one answer. So it's totally fine for an equation to have more than one answer, because I can plug in 8 and -8, and they both work in that. But an expression is like a mathematical thing that I'm just trying to simplify without an equal sign, just square root of 64. That's an expression. An expression just has one output. Okay, that's a key distinction there. Alrighty, so let's flip the page here. Let's do some more examples. So part H, what if I have negative in front of my square root of 64? Well, we know what square root of 64 is. We just did it. It was 8, and we have a negative sign in front of it. So that just stays there. Cool, so my answer is -8. In part I have a different type of root. I have a cube root. Cube root of 64. So this is asking me, what do I cube to get 64? What number multiplied by itself 3 times is 64? Oh, so it turns out 4 works. 4 works. So the answer to cube root of 64 is 4. Awesome. All right, what about for J? For J, I got square root of -64. But we've seen stuff like this in the previous section. You know, when I try to square root an even value, it's going to be undefined. It's going to be undefined. The even root of a negative number is undefined. So even root means like a square root or a 4th root or a 6th root. Those types of roots of negative numbers are undefined. But what if I have an odd root, a cube root of -64? Well, I'm asking myself, what do I cube to get negative 64? So is there something that works here? So yeah, if I plug in negative 4 times negative 4 times negative 4, that is negative 64. So this time I do have an answer. It's negative 4. So an odd root of a negative is totally okay. Okay, and I want to end this video with another practice problem for you. So I want to have you try part L here. So take a minute to pause the video and try this one. 4, 3, 2, 1, pause it. Pause it and try L here. All right, so hopefully you did that. Hopefully you paused it and tried it. Let's go and talk about it now. Okay, so I have this fractional power, this 2/3 power. So, well, there's two ways I can evaluate this. Because one of those numbers means the power, one of them means the root. So I can either write this as 216 and do the squared first, and then after that, then do the cube root. I can do that, or I can do it the other way around, or I can do the cube root first, cube root of 216, and then whatever that is, take that whole thing, and then end up squaring it. So I want you to take another kind of quick 30 seconds here. I won't say pause, but you should pause the video and think about this. One of these is much quicker than the other. Take a quick 30 seconds, see if you can figure out which one of them is going to be much quicker than the other. Okay, so it turns out the much quicker one is the second one. Because with the second one, I'm doing the root first. So I might have to think about, what's cube root of 216? Like what number cubed is 216? I have to think about it a little bit. But eventually we'll arrive at 6. So that cube root is 6. And then I end up squaring that number. So 6 squared, well, that's 36. And that's my answer. If I had tried to do this the other way, I would have to square 216. That's hard to do. Like, I don't even know what that is in my head. I got a huge number, and then I got a cube root, that really huge number. That's doubly hard. So the moral there is, in general, if you have to raise a number to a fractional power, it's almost always better to root it first and then do the power, because you'll be working with smaller numbers than if you did it the other way around.